Hey guys, let's go ahead and take a quick look at this quiz that you had over the weekend here. While I'm thinking about it too, Tyler, you had set up like three different accounts on here, and just in trying to figure out which one was which when I was grading and stuff, I ended up deleting the wrong one on accident, so I just deleted all three of them. So you'll need to go back and create a new account, and then I can just go back and manually enter the grades for the quizzes that you've already done. So if you're wondering why you can't get logged in, that's why. All right, so number one here, explain using complete sentences why n minus 2 is multiplied by 180 in our interior angle formula, n minus 2 times 180. What I was really looking for here was that you referred back to what we talked about in our notes right here. Okay, we're taking any polygon and we are drawing all possible diagonals from one vertice. Okay, this splits a polygon into triangles. Okay, each polygon will be split into a different number of triangles. Hold on just a second. I forgot to open this up. Each one of these polygons, depending on how many sides it has, can be broken into a different number of triangles. And each one of these triangles measures 180 degrees. And so once we divide this up into triangles, then we multiply it by 180 because all triangles have 180 degrees. Okay, but again, this all depends upon how many sides I begin with, how many triangles are going to be able to be created. Okay, so with a four-sided figure, we have one diagonal, two triangles, so we have 2 times 180. A five-sided figure, I'm able to create three triangles, so I have 3 times 180. So if you did not jot this chart down in the notes from last week's lecture video, then go back and jot down this chart and just maybe highlight this part of it in particular, the relationship that exists here between the number of sides and the number of triangles that exist. Okay, and that's coming from, again, those triangles are, we go from one vertex and draw all possible diagonals, and the diagonal would only be here because this is not adjacent to this diagonal. Okay, so you got some partial credit, some of you did, for some of the things that you said, but even if you told me some things that were true, that doesn't necessarily mean you're going to get credit for the answer. You still have to refer back to the question at hand. Okay, number two, what is the difference between a regular polygon and an irregular polygon? And most of us got at least part of this right. A regular polygon has congruent sides and congruent angles. An irregular polygon does not. So if you do not have that jotted down in your notes somewhere, make sure that you get a regular polygon, congruent sides, and congruent angles. So be on the lookout for this word regular in your directions for problems. Okay, that is going to play a pretty big role in whether or not I'm able to do some things and use certain formulas. Okay, find the sum of the interior angles of a dodecagon. Well, first of all, we have to know what a dodecagon is and how many sides it has. A dodecagon has 12 sides, and I have a formula that allows me to find the sum of the interior angles. That was the formula that we were talking about in number one. Okay, so my formula here is n minus 2 times 180 degrees, where n represents the number of sides. And we said that a dodecagon has 12 sides. So we do 12 times 2 times 180. Do your parentheses first, following the order of operations to get 10. 10 times 180 is equal to 1800 degrees. What this means is if I have a 12-sided figure, and I can't draw that, so I'm not even going to try. But let's say that, just for the sake of argument, that this thing does have 12 sides. Okay, if I had a 12-sided figure and I added up each angle on the inside here, and I went around and kept adding up all 12 angles, then I would end up with 1,800 degrees. Okay, next question. Find the angle measure of one interior angle of a regular nonagon. So instead of looking for the sum, now I'm looking for one interior angle, and it's a regular nonagon. So what this means is I have a 9-sided figure. That's what a nonagon means, a 9-sided figure in which all angles are the same. And again, I can't draw this, but what I can tell you is that whatever they are, whatever these angles are inside this 9-sided figure, they're all the same. So 1, 2, 3, 4, 5, 6, 7, 8. I'm sorry, 9. If I added all these angles up, that's going to give me the sum. Okay, but I only want one of those. And so what I'm going to do is, instead of using the n minus 2 times 180 and stopping there, I'm going to do n minus 2 times 180, where n is equal to 9. And this is going to be 7 times 180 degrees, which would be, I don't know, hold on, 1,260 degrees. Okay, this is the sum of all of the angles. Okay, and all of them are the same. So if I only want to know what one of them is, since they're all the same, I can take the total and divide it by how many of them there are. Okay, so that's exactly what we're going to do. We're going to take the 1260, divide it by 9. $12.60 divided by 9 gives me 140 degrees. Okay, so inside my 9-sided figure, I have 9 angles that are 140 degrees each. Okay, so if I went back up here and plugged in 140 for each one of these x's and added them all up, I would end up with my 1,260 degrees. Okay, so I'm still using this same formula, this n minus 2 times 180, to find the sum. And then once I find the sum, since it is a regular polygon, I divide it by the number of sides to figure out what one of those sides is. All right, and your last one here, this is kind of the opposite of number 4. Instead of finding one of the interior angle measures, you're given one of the interior angle measures, and you're trying to find the number of sides. Okay, so since it's basically the same problem, just the reverse of it, we're going to be using kind of the same approach, or the same formulas, so to speak. So before, I had n minus 2 times 180, right, to get the sum, and then I divided that by how many sides there were to get my one interior angle measure. Okay, this is what I ended up doing. I found the sum, divided it by 9, that gave me my 140. Okay, well, if I do that here, I already know what the answer is going to be. It's going to be 144 degrees. They told me that the one interior angle measure is 144. And this is what I did to find that in the previous problem. So I can set these two things equal. Okay? And then I have an equation that I can solve for n, which is what I'm looking for. N represents the number of sides in a polygon, which is what I've been asked to find here. So the first thing in solving this is multiply both sides of your equation by n. To get rid of this division, I multiply it on the right, I have to multiply it on the left also. That gives me 144n is equal to n minus 2 times 180 degrees. Okay, and this is where you started in the book. The example that we worked in the book started right here. But I wanted to kind of explain it to you in a different way and take a different approach just in case maybe this way made a little more sense to you. Okay, and then from here, I'm going to distribute my 180 degrees. So I've got 144n is equal to 180n minus 360. And now I'm just solving an equation. Subtract 180n from both sides. Leaves me with negative 36n is equal to negative 360. Divide by negative 36. And you end up with n is equal to 10. Meaning that the polygon has 10 sides. And then how can I check to make sure this is correct? Well, what I'm saying here is that a 10-sided figure will give me an interior angle measure of 144 degrees. Okay, so go back and plug your 10 in and follow that same procedure that we did to answer number 4 and see if you get 144, and you will here. Okay, so we'll continue to get some more practice with these type problems as we move forward here. This will be a concept that's going to be included on your next test. If you still have any questions or concerns regarding this quiz, please feel free to message me on Schoology. I've had several people message me thus far, which I'm very excited about. Please continue to do that. Ask me questions. You're not bothering me, I promise. I would much rather have you ask me the questions now than just wait and become more confused, and then when I get back we have a lot more work to do. Okay, so go ahead and message me with anything that you have, and I'll get back to you as quick as I can.